March 2019, paper 1, question number 15. Part A. It says for 4 marks. Solve the equation sine 2x plus 6 cos x is equal to 0. X is greater than or equal to 0, less than 360. So that's your domain. This is for 4 marks. So this, you need to expand the sine 2x to give you 2 sine x cos x plus 6 cos x equals 0. You can take a common factor of 2 cos x out. That leaves you with sine x plus 3 equals 0. This means that cos x is equal to 0. If you look at the cosine curve starts there and then goes like that. So cosine is equal to 0 at 90 degrees and to 70 degrees. So it's 0 at 90 degrees and to 70 degrees. So that means that x is equal to 90 degrees and to 70 degrees. So these are your only two solutions for part A. For part B, hence solve the equation sine 4x plus 6 cos 2x equals 0. Again, your domain is x greater than or equal to 0, less than 360. This is just for 1 mark. So you've already done the working there, but there's a bit more involved here. You can maybe just spend a bit more time. So you got sine 4x here. Okay, so sine 4x. When you expand sine 4x, you get 2 sine 2x cos 2x plus 6 cos 2x equals 0. Taking out a common factor, you can take out 2 cos 2x. Inside you're left with sine 2x plus 6 equals 0. So what you have here is the other part here in part A, which I forgot to mention, is sine x plus 3 in the other bracket equals 0, which means that sine x is equal to minus 3. The sine curve has an amplitude of 1, so there are no solutions. So there are no solutions there. No solutions. As sine x is greater than or equal to minus 1 and less than 1. So there is no solution at sine x equaling minus 3. So there is no solution to that. The only solutions are in the first bit here, where cos x equals 0 and then x is equal to 90 degrees or 270 degrees. In this case, in part B, 2 cos 2x equals 0. The 2 divides into the 0, so you're just left with cos 2x is equal to 0. Cos 2x, this means that there are 2 cosine curves between 0 and 360. So you're ending up with 2 cosine curves. There's one and there's the other one. So there's 2 cosine curves between 0 and 360. There's 360 degrees there. This is 0. Now, this is your y-axis, this is your x-axis. So your cosine curve in this case, in the ordinary cosine curve, this turns every 90 degrees. It changes direction every 90 degrees, changes gradient every 90 degrees. So there's 90 degrees, 90 degrees, 90 degrees, 90 degrees. In this case, it changes every 45 degrees. So this point here is now 45 degrees. This would be 90 degrees here. Now you're adding another 45 there, so this is going to be 135 degrees. This in the middle here is 180 degrees. Adding 45 there, that gives you 225 degrees here. Again, adding the 45 there would give you 270 degrees. And adding 45 there gives you 315 degrees. Obviously, then adding the 45 takes you to 360. So your solutions here, you've got more solutions here. You've got one solution is at 45 degrees. There's another point where it cuts the x-axis is at 135 degrees. It again cuts the x-axis at 225 degrees. And finally at 315 degrees. So that's your solutions to part B. The other way you can look at it is you've got these two, so if you add the 180 to the 45, that would give you the second solution there. If you add 180 to the 135, that would give you the fourth solution. So you could do it that way, or you can look at the curve. Curve makes it a bit more obvious, and that's the solution to part B.